All right, guys, I'll show you what I did, all right? I did I think I did 4. Something like this. Okay? I think I used 4 and it was similar to. Now, let's check this out. Rise to run, you just need any 2 points on the line. So this one, I'm going to use this one and this one, let's say, okay? And I've got 0, 15, and I've got this one, let's say, not 0, 15, 90, 15. This one I've got 95 all the way up to 22. So my rise, I'd go from 15 up to 22 for a rise of 7, and I go from 90 to 95 for a run of 5. So maybe I say 7/5 for this first one. You just have to be ballpark, right? I did it a second ago with you, and I got 2. It's not very accurate, right, on here. So I got this point. Let's go from this point to this point. This second point looks like it's probably like 2005 and all the way up to 24, okay? So how much did that go up by?
A lot.
22 to 24. And then my run was over how many years? 10 years? So that is a slope of 1/5. So my slope's smaller. Is that line less steep? Yeah, that's nice. So I got that point. Let's look at this point. This point's something like 2011 all the way up to 28. So it goes from 24 to 28. How did it go up? 4, and then it went from 2005 to 2011.
6.
So that's a slope of 2/3. And my last one ended at, what year? Do we want to say 2014? And that ended at 25? That might be 25.5, but let's say 25. So that one went down 3 over 3. A slope of -1. Excuse me. So these would just be ballpark. You could have had something really close. Big picture, this should be the biggest positive, this should be negative, and this should be the smallest positive, because everything's relative with slope, right? Slope's the rise to the run. If there's time later, I'll sing the slope song to you, all right? So, who can help me with my independent and dependent variables? Independent and dependent. Zeph?
Gallons, that's what is the y-axis, is dependent on time, which is in minutes, which
Yep.
is on the x-axis.
Yep. So time determines how much is in this bathtub. When did she turn off the water? And how do you know?
She turned off 6 minutes. I know.
I'm looking for the universal. Sean.
She turned off the water at 6 minutes.
Okay, 6 minutes. And how do you know that?
Because the graph shows that it's filling up until 20.
Yeah, that's not right. I saw some people write 6. Is that 6 days?
Oh, it's 6 minutes.
How do I know it's minutes unless you write in minutes? So, units are the bomb.
So that's 6 minutes. She did.
So it said when, so it's looking for a time. Yep. 3. How much water is in the tub when she bathed that doggy?
24.
Yeah, 24 gallons. Gallons are dumb. I like liters more myself. 4 quarts in a gallon, 2 pints in a quart, 8 ounces in a cup. Just move a decimal. We're in the metric system, baby. All right, number 4. How long did it take for the tub to drain completely? Josiah, you got this for me?
It took -12 minutes.
12 minutes to drain? Dang, man. That seems like a bad. Maybe there's a bunch of dog hair in it. That's what I was thinking. All right. At what rate did it fill? And how did you get a rate? JP?
4 gallons a minute.
How'd you get there? I don't see 4 anywhere.
After 3 minutes, it was at 12 gallons. So if you do 12 divided by 3, that's 4.
Okay. So, I like that you went to this spot. Oh, look at that works. 12 divided by 3 or 24 divided by 6. I'm guessing more people did 24 divided by 6.
I didn't do half.
Oh, maybe not. That's what I did.
That's way harder.
Okay, here's something I want to point out. Here's it's really good how I liked how JP told me. He said gallons per minute. If it's a rate, we need to compare two different units, right? So you need 2 units. Sometimes you could write this as 4 gallons over 1 minute as well. That's still cool. 4 gallons per minute. And what is the rate at which it drained from that tub? Rat.
Negative 2 gallons.
So, yeah.
Wait. Oh, it has.
So it's leaving. It's leaving at 2 gallons per minute. Unless, here's one thing I thought about. I like to think about like, oh, how could I mess with this? What if it was actually draining? Hear me out. What if it was actually draining at 6 gallons per minute, but they still had the faucet on full blast? The graph would still be true. Oh my goodness. But I don't think that's the intent. But that's just the way my brain works. It's like how you wrong. But it still be right. So I want one person to give me some of their data points, please.
No.
All right, let's hear it.
So I had the height was 1,
Okay.
and the volume ended up as pi.
Okay, give me more data points, please.
And the diameter,
No, I want like volume to height rate.
volume to height.
Yeah, from the rest of your table.
Oh, I only got 1.
Oh, one's not enough. Okay, who's got some data points for me that we can look at? All right, Susie, let's hear.
Got volume is 39.7 and height is 2 centimeters.
Okay, give me more.
The volume is 46.6 and the height is 2.4 centimeters.
Okay, and so give me one more.
That's the highest I have. Should I just go lower?
Yeah, lower's
All right,
good.
16.1 milliliters for volume and the height is 0.8 centimeters.
Okay, so with these 3, what you're going to notice, and I'm not going to write it much bigger. Everybody noticed that if you had volume and height, that at 0 and 0 you had something, but then we had a linear relationship, right? And it's a cylinder, right? So as you keep filling it, it's going to go up at the same speed over and over as long as your fill rate's the same. You feel me? Right? So that would work with cylinders. What else could it work with? That like it would go up. So we got cylinders.
In this situation? Or
Yeah, they're shaped like this. We got a cylinder, but any other shapes that would fill? Do you think?
rectangular prism?
Rectangular prisms? So let's think about it. So if it was something like this, right?
But it can't be
It'd fill. Well, if it's like perfect parallel basis, it.
No, I'm saying like an example of something that wouldn't work with you.
Oh, a non-example. Yeah, let's think of a non-example. Let's try. You filled a cone. You could get in the tip of it. Let's say it'd fill slower, and gradually it would fill faster and faster and faster because it's smaller at the top. Right? Are you seeing that?
Yeah.
So everybody should have been linear for this, regardless of your radius. Correct?
Okay.
So over time, it filled at a rate. So checking this out, this is a container that's getting filled. What do you notice happens to the rate at which it's filling at some point?
It gets slower.
It gets slower. So a graduated cylinder wouldn't get slower. It's the same, right? It's the same all the way up. So this one is a little faster. So I'm going to draw this cylinder. And then if how much it's getting higher slows down, what has to be true above this cylinder?
Oh, it's like one of those this way, yeah?
So this cylinder is represented with this portion of the line. But what happens after this cylinder gets full?
It starts.
Zeph?
There's like another bigger cylinder.
Yeah, there would have to be another larger diameter cylinder above it, right?
Hang on.
Because that is filling up slower.
Oh. Oh, never mind.
Look at that. That's kind of a cool container. It wouldn't have to be a cylinder. It could be a prism. It can't be a pyramid, though. Can't be a sphere. Sphere would be like fast, slower, faster. So you're going to do problem number 2. Same idea. But what do you notice is the difference before you tackle problem 2? What's the difference?
Graph's different.
Well, it is, but what's different about it? What is that? Yeah, so this one just changed once. That one's going to have 2 changes. Let's see what you get. We're up against it here. So, who can explain to me what has to happen for this graph to work? Where does the smallest piece have to go? Let's handle that. Where would the smallest piece or narrowest piece have to go? In the middle, yeah, and why do you say that? So faster means narrower. So that bottom one that I'm going to put on first, is that going to be the biggest, smallest, or middle?
The bottom one, wait.
It has to be the middle. It's the middle slanty line, right? So I'm going to make it like this big. So there's my bottom one. Relative to that bottom one, what has to happen next, though?
It has to be skinnier.
It has to not only be skinnier, but it has to be the skinniest. That's the steepest part of the fill, right?
What about the height of them?
Yeah, it does matter with overtime, but we're just trying to make a general representation. And then the top piece, what do we know that has to be true about the top piece? It has to be the thickest. Let's call it thick, Vic. And I know it has to be the thickest because that's got the lowest slope. It's filling the slowest. All right? Nice. I like those. I went with like a pastel kind of vibe there. I'm digging my vibe with the colors.
That green pastel, not really.
I don't know, man. It reminds me of mint chocolate chip or something. That's that. So, last thing I want to point out. Today we saw functions as equations, graphs, tables, situations, and geometrically. Wow. Lots of ways to show function. Because math is
Also, hard. Radical.
communication is what I was looking for, but also lit.